G'day everyone. Please mind the voice. I've currently got COVID, so still working through a bit of a sore throat. But today we're going to have a look at where functions meet, and more specifically, we're going to look where linear functions and quadratic functions meet. So we're going to consider looking at them on the same set of axes. So when we do this, we can actually have three different scenarios. All right, so we can have on this left-hand side here, we can have them cutting. So 2 points of intersection here and here. We can have them touching, or well, another way we could say this, we could have our linear function as a tangent to our quadratic. So that means it just touches at 1 point or 1 point intersecting. And then our final one, we can have them missing entirely. So 0 points intersecting. All right, so a bit of an example of questions you might see that involve this. All right, so probably the most common question you will find is finding the coordinates of points or point of intersection of the graphs with specific equations. So the two equations we're going to look at, y equals x squared plus x take 2 and y equals 3x plus 6. So on the left-hand side, we have our quadratic function. On the right-hand side, we have our linear function. All right, so we want to find where these two meet. So that means we're going to make them equal to each other. And because they're both equal to y, we can easily do this by saying x squared plus x take 2 is equal to 3x plus 6. And this will find the x coordinate of our intersection points. What we're going to do, we're going to get everything over to one side and make one side of our expression equal to 0. So I'm going to take 6x and 3x from both sides, all right? So that's going to result in us getting x squared take 2x take 8 equals 0, which is exactly the form we want because we know how to factorize and solve for our zeros of a quadratic equation. So I'm going to use my sums and products, finding two numbers that multiply together get -8, but add together to get -2. We find that those two numbers are -4 and +2. So we can rewrite our equation in factorized form as x take away 4 multiplied by x plus 2 equals 0. Using our null factor law, we can find that x equals -2 and x equals 4. This will mean that our two functions will meet when x equals -2 and x equals 4. So to find that y coordinate, okay, we need to substitute back into one of our original equations. Clearly, our linear equation is much easier. All right, so we're going to substitute into that one. When you substitute in x equals -2, you get 3 times -2, which is -6. -6 plus 6 equals 0. So when x equals -2, y equals 0. We're going to do the same thing, but with x equals 4, and hopefully you find that y equals 18. Therefore, the points of intersection are -2, 0, and 4, 18. You can also check this with your calculator by graphing them, okay? Example number 2, all right? This is probably another very common one. It will ask you to find an unknown in one of the equations. So in this case, if y equals 4x take away k is a tangent to y equals x squared take 3x plus 2, find k. All right, so we're going to look at the exact same process. So these two equations meet when equal, so we equate them as such. We're going to take everything over to the same side to make one side equal to 0. And we're going to collect our constant terms together as our c coefficient, okay? So because we're given the information that our linear equation is a tangent, we know that they touch once. So if you're playing along with the Hazy textbook especially, so in chapter 2D.4, when the quadratic touches the x-axis, our discriminant, so remember delta is our discriminant, equals 0. So the same thing actually applies here. So we can take our new quadratic, all right, find the discriminant when that equals 0. Our linear equation is a tangent to our quadratic. So we're going to do that. So delta equals b squared, take 4ac, formula for our discriminant, substituting in our b value, our b coefficient, which is -7, our a coefficient, which is 1, and our c coefficient, which is 2 plus k. And we're just going to slowly solve for k, all right? So multiplying this 4 into both terms, solving our constant terms without our variable, taking that from both sides, and then dividing through by -4. All right, so they're the two main questions you will find when you're looking at where two functions meet. All right, thank you, and we'll see you next time.